We've been going over this idea of adding integers either with the same sign or with different signs, right? So we've seen problems, like our typical math problems, 7 plus 8, where it's pretty straightforward, it's 15. But now we've also been introduced to this idea where we have a number like 7 and we add it to a negative number like a negative 8 seen here. So, can you remind me of the strategy that we use, our sort of three-step process that we use to add these two numbers together, if the numbers have two different sides? Oh, yeah, totally. So, can you remind me of the process that we use in order to add numbers that have two different signs? Okay. Really, really close. Your steps 1 and 3, 1 and 3 were spot on. So I'm glad that you're sort of getting closer to committing this to memory. Instead of adding those two numbers together, we subtract the number with the greatest absolute value from the number with the less absolute value. So let's use this example right here. So you said our first step was to find our absolute value. So what would be the absolute value of these two numbers? Seven and 8. And then what was our next step? And what number do we subtract from what number? Okay, and why do we do 7 minus 8 instead of 8? Oh, go ahead. 8 minus 7, right, that's correct. And why is it 8 minus 7 instead of 7 minus 8? Right, and that's exactly the right idea. We do the number with the biggest absolute value. Because technically, is negative 8 bigger than 7 or smaller than 7? Okay, so the absolute value is big. Go ahead. Right, exactly. And so I'm glad that you caught yourself sort of worked through it in your head, but you're totally right. Negative 8 is technically smaller than 7. The absolute value of negative 8 is bigger than 7, so we take the number with the bigger absolute value. 8 minus 7 is equal to 1. Now, how do I know if this answer is negative or positive? And which number is our bigger number in this case? Exactly. So we have this process when there are two numbers with different signs. Let's roll through one example really quickly, just sort of refresh ourselves. Let's say we have negative 10 plus 18. So how am I going to solve this problem? Right. Okay. Perfect. And that's something that we practiced a little bit yesterday. And so let's go over that right after we finish up this problem. I'm glad that you brought that up because that's exactly where we were going. So in this case, our absolute value of negative 10 is 10. Absolute value of 18 is 18. What number do we subtract from what number? That gives us 8. How do I know if this is negative or positive? Exactly. Right, exactly. That I couldn't have said it better myself. Cool. So you mentioned, I'm glad that you mentioned we're adding negative numbers to negative numbers. That's something that we started to go over yesterday a little bit. And our process for adding two numbers with the same sign is to take the absolute value of the numbers, add them together, and then use the sign of the numbers for our answer. So let's walk through that really quickly. Let's say we have negative 8 plus negative 7. And this is what you were talking about, right? Where we're adding two negative numbers together. Okay, cool. So our first step is to find the absolute value. What's the absolute value of these two numbers? And now what we do is we add the absolute values together. 7 plus 8 is 15. And then we use the sign from these numbers to find the sign of our answer, which is negative 15. Does that make sense? Okay, good. Do you have any questions about the process of adding negative numbers to negative numbers? Okay, good. And just to sort of confirm that this is negative, if we have negative 7 and we want to subtract 8 from it, are we going to move to the left or to the right on the number line? To the right? And why is it to the right and not the left? Right, so imagine we jump over 8 spaces and we end up, right, if this is 0 over here, our number is getting smaller and smaller, or more negative and more negative, rather. So we can see that when we add two negative numbers together, the actual number gets bigger, but it becomes a bigger negative number. Does that make sense? Okay, cool. Let's practice that one more time. Let's do negative 26 plus negative 13. So what's our first step here? And what's the absolute value of negative 26? And of negative 13? And what do we do to these numbers? Do we add them, subtract them, divide them, multiply them? Exactly. Now, is this answer done, or do we need to change its sign to negative? Exactly. Cool. So, do you have these steps written down? Sort of the two scenarios where if the numbers are the same sign, we have a set of steps, and if we have numbers with different signs, we have a set of steps. Do you have this written down somewhere? Okay. So let's get this written down so that if we ever forget it or we ever are doing our homework, we can look at it. And the more that we repeat these steps over and over again in our head, commit them to memory, the easier it's going to be to do while we're on the test. So let's start with two numbers of the same sign. Right, we take the absolute value of the numbers as our first step. Our second step would be to add the absolute value of the numbers. And then finally, we use the sign of the two numbers in our answer. And just let me know when you have this written down. We can move on to the set of steps for the next type of problem. Okay, good. So that's two numbers with the same sign. Adding two numbers with a different sign. We find the absolute value of both numbers as our first step. Notice that that's our first step regardless of if the signs are the same or different. And a more visual way to write this step number 2 down that might be easier, so we don't get confused, is just bigger minus smaller. Instead of writing down a sentence, I don't know. For me, I'm a little bit more visual with this stuff. I like to see sort of equations rather than words, because words can be annoying sometimes. And then we use the sign of the number with the bigger absolute value for our answer. And just let me know when you're done writing all this down. Okay, good. Before we move on, do you have any questions about either of these processes? Okay, cool. No questions about how to determine the sign of our answer, or what number to subtract from what number, or anything along those lines, or are you good? Yeah, 100% of the time. And it's not necessarily the bigger number, it's the number with the bigger absolute value, right? Because, for example, in this step right here, we decided that, or for example, if we have the number -7 and 8, or sorry, -8 and 7, right? We decided that 7 was bigger than -8, right? And in this case, this is technically the bigger number, but if we're talking about absolute value, 8 is the bigger absolute value, and if we were to add these together, the answer would be negative. So it's the number with the bigger absolute value. Does that make sense? Cool. Awesome. Any more questions? Okay, good. Okay, good. I'm glad that you're asking questions about stuff. That means that we're learning. So I love it. Have you guys worked on adding fractions or decimals at all, or have you just been working with integers? Okay, well, we have some extra time. Do you feel like you want to practice this process with more integers, or do you want to start moving a little bit ahead and work on fractions a little bit? Okay, good. I think from what I've seen, you're really good on this process, and you're going to be able to practice it more and more. So let's talk about fractions a little bit. So just in general, say we're adding two positive fractions, say 3/4 plus 2/4. First of all, in general, how do you feel about fractions? Do you understand them? Are they kind of scary? Do you get them? Okay, good. Like many things in life. Okay, so in this case, how would we add these two fractions together? Okay, so what I like about that process is that you added the right, are you familiar with the terms numerator and denominator? Yeah, so the numerator is the top number. Bottom number is called the denominator. So you added the numerators, which is good. And the only problem with your process is that we don't actually add the denominators together. And I could sort of show you why right here. Let's say we had a box that was split up into 4 parts. And let's say we were adding 1/4 and 3/4 together. So by your logic, if we added these two together, we would add the numerators, which would be 4. We'd add the denominators, which would be 8. 4 over 8 simplifies to 1/2. Now, let's see if this makes sense. So if we take 1/4 of this box, and then we add 3 pieces of this box to that 1/4, we can represent that with the shading. All of the boxes are shaded, right? So 4 out of the 4 boxes are shaded, which means that 1/4 plus 3/4 is equal to 1. Now, doing it the way that you said, our answer was 1/2. So it's not quite right. But can you see conceptually how adding the denominators doesn't actually give you the right answer? Okay, good. So I guess we can write down a series of steps for adding fractions. The first question that we can ask is, are the denominators the same? And I recommend writing this down, because you are going to deal with fractions for the entirety of your math career, however long that is. So it's good to get these rules down, or at least familiarize yourself with them. Well, you can. So if yes, if the denominators are the same, we add the numerators, and we keep the denominator the same. I'll say that one more time. If the denominators are the same, we add the numerators, and we keep the denominator the same. Does that make sense? Okay, good. Let me know when you're finished writing this down. Okay, good. And we can write a quick example right here to remind ourselves. 2 over 4 plus 1 over 4. Are these denominators the same? So what do? We add the numerators. 2 plus 1 is 3. And what do we do to the denominator? Do we add them together or keep it the same? 3/4 is our answer. I like to write little examples underneath these words, just so, I don't know, like I said, words can be kind of annoying sometimes. So if I can actually see this, I can look back at it, and when I'm doing a problem, I can say, oh, look, this problem looks exactly like the problem that I'm doing right now. And it makes it a little bit easier for me. So if you'd like to do that, go ahead. If they're not the same, what we do is we have to find a common denominator. Does that word ring any bells? Does that sound familiar at all? Okay. So let's take let's take a look at a fraction where the denominators are not the same. So let's say we have, let's say we have 1/2 plus 1/4. Okay, so how would you go about finding a common denominator for these two numbers? Any ideas, any thoughts, anything you can remember? Yes. Yeah, exactly. A number that can go into both of them. That's basically the idea. A number that can go into both denominators. Couldn't have said it better myself. So, how do we do that exactly? How would we go about finding a number that can go into both denominators? Or both of these numbers, 2 and 4. Okay, so that's sort of the right idea, where 2 does go into 2 and 2 does go into 4. However, that's not quite right. And I'll tell you why that is. It's because the new number has to be at least as big as our biggest number in the denominator. I'll say that one more time. Our new denominator has to be at least as big as our biggest denominator. So I guess this is a good idea, and it's worded beautifully, but it's not entirely correct. So another way to say this is, we can check, we could say 1. I think the best way to say this is, what's the smallest number? That both denominators both go into. And we'll elaborate that a little bit more next week. But basically, I would say the easiest way to find a common denominator is to multiply the two denominators together. That's usually the easiest way to do it. Sometimes you can get a smaller denominator, but most of the time it works out really well. So the way we do that is we take the number that's on the bottom here and we bring it over to this side, to this number, and we multiply 1/4 by this number over itself. And we do the exact same thing over here. We take this number, we put this number over itself. So now we have two sort of things we're working with right here. So let's simplify these a little bit. So when we're multiplying fractions, are you familiar with multiplying fractions? Good. So what's the rule for multiplying fractions? That is dividing fractions. Good, and I'm glad that you have that engraved in your memory. Multiplying fractions, it's the easiest one out of everything. You literally just multiply it across. So what's 4 times 1? 4 times 2? Plus 1 times 2 times 4 times 2? Are our denominators the same? Okay, so can we add these fractions together now? Yes, right? Which we wrote down, because if the denominators are the same, what we do is we add the numerators and keep the denominators the same. So we add the numerators. 4 plus 2 is 6. Do we add the denominators or do we keep the same? Right, we keep it the same. And this is our fraction right here. Does this process of finding a common denominator make sense to you? Okay, that's a good question. So, the reason that we're allowed to put 2 over 2 anywhere, here's a question that sort of answers your question. 2 over 2 is a fraction here, but it also means 2 divided by 2. And what's 2 divided by 2? And it's because any number divided by itself is equal to 1. Now here's a question. Let's take a look at 1/4 times 2 over 2. So if 2 over 2 is equal to 1, I could write this like this. Do you see how I got from here to here? Right, because any number divided by itself is equal to 1. Does that make sense? And what is any number times 1? Equals itself. So 1/4 times 1 is equal to itself. So did I actually change this 1/4 at all by multiplying it by 2 divided by 2? No, I didn't. And this is an idea that we use in math. You'll see it all the time, everywhere, for the rest of your however long you do math for. Sometimes we'll change numbers in a way that doesn't actually change them, but changes them in a way so it's easier to work with. So does that make sense? So what I did is I said, okay, I want to multiply this number by 1, but I want to be able to add these numbers together. So what I do is I multiply by 1, right, which we proved, but I multiply by 1 in a way that lets me add the two numbers together. Does that make sense? Okay, good. We're going to go over this idea of